Hello, geometry students. It's Mr. Allen here, and today we're going to move on to Chapter 5. We're going to actually cover two sections today. We're going to cover midsegments and perpendicular and angle bisectors. So our objectives are twofold. We want to be able to use the properties of a midsegment of a triangle, and we want to also use the properties of perpendicular and angle bisectors of triangles. So I'll have you guys do an activity in class. We'll actually skip that for this video here. But here we have theorem 5.1, which is the triangle midsegment theorem, which basically says the following. If we have the midsegment of a triangle, and the midsegment is simply this segment here, which joins the midpoints of these two sides. So D is the midpoint of segment AC and E is the midpoint of segment CB. It turns out there are two conclusions to be drawn here. If that is a midsegment, conclusion number one, then these sides here, DE and segment AB, are going to be parallel. That's number one. And number two, it turns out that the length of DE, that's this segment here, will be half of the length of segment AB. So let's see an example of that. It says, what are the three pairs of parallel segments in triangle DEF? Okie dokie. Well, let's see here. This segment's congruent to this segment, and this segment's congruent to this segment. So that means that this is the midpoint and this is the midpoint. Therefore, this side has to be parallel to this third side over here, EF. So I would say that segment RT is parallel to segment EF. And also, we also know that the third side is S is a midpoint of the third side. So then that implies that RS is parallel to segment DF. And of course, we have one more here, and that's this one here, this segment right here. So we'll say that segment ST is parallel to segment ED. So we had three midpoints, so therefore we'll end up with three midsegments of the triangle. Okay, so triangle QRS, TU and B are midpoints, thus they are what we call midsegments. And we want to find the length of TU. So let's start with TU. So TU is this segment here, and it is the midsegment of the side QR and QS. So it has to be half of the length of this side. In other words, the length of UT, or actually let me write that in the correct order here. Let's erase that. The length of TU has to equal 1/2 the length of RS. Well, we know RS is 40, so it's going to be half of 40. So it has to be 20. So TU, the length of TU has to be 20. Now let's find UB, the length of UB. The length of UB, now UB is this guy right here. It's got to be half of this length here, so it's going to be 25. And we've got one more. We want to find QR. QR is this length here. Now this is interesting. The mid segment here is 30. So I'm going to say that TB is equal to 1/2 of QR. Well, and we know that TB is 30 is equal to 1/2 of QR. Therefore, QR has to be 60 because you would multiply both sides by 2. So there's our three answers for this one. And that is using this theorem. The midsegment of a triangle will be parallel to the third side, and it will be half the length of the third side. All right, section 5.2 has two kind of theorems, and these are converses of one another. The first one has to do with the perpendicular bisector of a segment. So I'd just like to remind you that a perpendicular, if I have a segment here, we'll call this segment here AB. And I do the perpendicular means it has to form a right angle. And if it's a bisector, that means it has to divide it equally. The perpendicular bisector, and then and so now I'm going to get into the first theorem. The first theorem says that if you have a perpendicular of a segment and then you pick a point on that segment, I'll call it point P right there, let's say. This is point P. It turns out that it is equidistant to those other 2 points. And we can see that in this picture here. So PA has to be equal to PB. The converse of that is also true. So if you have a segment and a point not on that segment, and if it turns out that this distance is congruent to this distance, then it has to lie on the perpendicular bisector. And furthermore, this has to be congruent to this, which is again the perpendicular bisector characteristic. So let's look at that as in an example. So it says find the length of segment AB. So we're trying to find this length here. Let's see here. What do we have here? We have something that is perpendicular. You see the right angle, and it bisects. So this is indeed a perpendicular bisector. Oops, if I can put bisector in there. It's a perpendicular bisector. And if it is and let me just make that more explicit here. If BD is the perpendicular bisector of AC, which it is based on the given information in the picture, then we can conclude that I'll put then, BA has to equal BC. And so that's what we need to do in this problem. We just need to substitute, well, what's BA? 4x. What's BC? 6x minus 10. And so we can go ahead and solve that. I would subtract the 4x over to the right. That gives me 2x. So it looks like x is 5. And if x is 5, then BA, which is 4x, will be 4 times 5, which is going to be 20. So the length of BA is 20. All right, last theorems for the day. This one involves angle bisectors. Angle bisectors. So if you have an angle bisector of an angle, so in this example, let me draw you a picture. So let's say I have this angle here, and then let's say I draw the angle bisector. The angle bisector just means that it divides it into 2 congruent angles. And then let's say we pick a point on that angle bisector. I'll pick this point right here. It turns out that this distance and this distance are equal. Remember, distance from a point to a line is the perpendicular segment's length. And of course, the converse is true. If a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. So let's go and look at our fourth and final example. It says, what is the length of segment RM? So we're looking for this length here, RM. Well, let's see here. I know that this angle is congruent to this angle, so therefore I know that ray RN is an angle bisector. The angle that it bisects is angle MNP. Therefore, I know that MR is the same length as PR. In other words, 7x is the same thing as 2x plus 25. Let's go ahead and show a little bit more work on this one than I did the last one. Let's minus 2x minus 2x. So I get 5x equals 25. X is going to be equal to 5 by dividing. Now we need to find the length of RM. So RM is equal to 7x. X turned out to be 5. So the final answer here is 35. And that will wrap it up. Thank you for your attention.